So how do we do fine adjustments for the XY calibration? So after we scan a certain area, a certain grid where we know the physical dimensions from a different system, so now we can open it with WSXM or with any other STP file processing, image processing. And here we're going to open the image which we saw here in NWS. And just a simple filter. And now we're going to check the dimensions. So first we're going to look at the fast axis. So this is not exact, the sample is not exactly set in such a way that the fast axis and y-axis are exactly parallel to the fast axis and y-axis, but we'll anyway still try to do it. It will give us a good approximation. So here I'm going over the holes in this sample where we know that the period between the holes is 1.2 microns. So let's have a look at it. So here, if we go to this one, then we go 1, 2, 3, 4, 5. We see here the distance is 8 microns. Now it should be 5 times 1.2, which is 6 microns. So we're quite off. So how do we fix this? So first of all, let's check in another place to make sure that it's okay, that it's not only one line which is off. Let's say, for example, let's check right here. So here also we have 1, 1, 2, 3, 4. That's a little bit hard to see. This 5. Here it's 8.3. Because also it's not exact here exactly where the center of the hole is, but more or less. So let's take an average. Let's check one more place and then we'll average it out. So let's go here. Here it is dusty where it is blocking. Take this down here. Let's go here. 1, 2, 3. 1, 2, 3, 4, 5. Here it's also 8, about 8. So let's keep it for 8 for right now, and then after we do another scan we can always continue to fine tune it. So here we see that we get 8, but it's supposed to be 6. So we go to the formula file which we used. We go to the NWS folder, formula, output. Let's say, for example, we use for the formula this file here. So we open it. And here we see the number for the fast axis. There's a number here. Okay, max range X, that's the fast axis. And also here. First of all, this and this number should be the same number. So, for example, now we have 84.849. Now, by the way, to know which number which we're using now in the NWS, so we can see here in the formula. Okay, let's just make sure it's this one. We'll choose something else, and then again this one. So we see here 4.26, whatever this number here. If we multiply that by 20, we should get the number which we have in the file. So 20 times 4.26245, 85,249, and it's the number right here. Okay, so we have to make sure that this number and this number are the same. Okay, so we're going to take 85.249 and multiply that by the ideal number by 6. Okay, we're supposed to see here 6 micron. Multiply that by 6. and divide it by the number which we measured now. So that's 8. Divide by 8. Okay, so that's 63.93675. So we take this number and we paste it into the file. We make sure we paste it here and here. Now this number seems to me a little bit low, so I would recommend to do another scan and to fine-tune it again, because mostly for a regular sample scanner for the MV2000, all this, the sample scanner are the tip scanners, so the range should be somewhere around the 80. So therefore this seems to me a little bit low, but it might be. The same thing we do for the slow axis. Let's go in this direction and let's try to choose a line. Now, it could be also these holes are not exactly, they don't seem exactly straight. That's why it's always good to use the grid which Nanonics supplies. This is not the Nanonics grid. Okay, so here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's make sure that makes sense. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so something was off. Let's try it again. 1, 2, 3, 4, 5, 6, 7, 8. That makes sense. Okay, so we see here distance 8.4, which is quite low. Okay, 8.4. Let's say if we go 5 like what we did before. 1, 2, 3, 4, 5. So here we get 5.362, and we should have got 6 instead of 5.3. So therefore we have to do again. We look at the range for the y, okay, which is right here, 96.934. Okay. And we multiply that by what we're supposed to get, so that's 6. We're going to divide it by 5.3. So the value should be now 109.73660. It's enough 3 numbers after the digits, so we can put 109.737. And of course, not to forget to do it here. And of course, we save the file, and then again, just to refresh it, choose a different one, and again choose the same one, and then scan again, and then check that we're not too off, and then you can like fine tune it this way until you get a scan which is more or less the correct formula. Now you have to remember that you will never get each scan exactly the same, because there's a certain resolution step for 2 reasons. One is because of the pixels. So for example, if you're choosing 10 microns and you have 256 pixels per line, so that means that you have, okay, so you have 10,000 nanometers to divide by 256. So that means that each step is almost 40 nanometers. So you can have a plus minus of, let's say, 20 nanometers to here and to there each scan. And of course also you have the tip size, which a regular tip size is also like 20 nanometers. So we're more or less talking about a 20 nanometer deviation. But mostly, if you can get to 20 nanometer deviation, that's a really good situation. because also, for example, you don't know exactly if this is the center of the hole or this is the center of the hole. So you also have here a certain deviation here. That's it for now.